Good day everyone, I am Ma'am Bueng, your teacher for today's video lesson. Our topic is all about polynomials. Here are the objectives for today's video lesson. First, we have to differentiate a polynomial from a non-polynomial. Second, perform division of polynomials using the long division. And the third one, follow the rules in dividing polynomials with perseverance. Let us first have an activity entitled Spot the Difference. Kindly get your scratch papers to answer this activity. So there are pairs of algebraic expressions that you have to compare. All you have to do is to spot the difference between the two expressions. Then draw a smiley face if the expression represents a polynomial and draw a sad face if the expression represents a non-polynomial. So let's start answering this activity. All you have to do is to draw a smiley face if the expression is a polynomial and a sad face if it is a non-polynomial. First pair of expressions, we have 2x squared plus 1 and 2x raised to negative 2 plus 1. So what's the difference between these two expressions? Obviously, the difference is the negative exponent in the second expression. So the question is, which one represents a polynomial and which one represents a non-polynomial? You're right. The first expression is a polynomial, while the second one is a non-polynomial. So since there is a negative exponent in the second expression. Next pair of expressions, we have 2 the square root of x and x the square root of 2. So the difference between these two expressions is the radicand. In the first expression, the radicand is x. In the second expression, the radicand is 2. So which one is a polynomial? You're right. The first expression is a non-polynomial, while the second one is a polynomial. This is a non-polynomial since there is a variable under the radical sign. Second pair of expressions, we have 2x cubed minus 3x raised to 1 half plus x minus 4. And we have 2x cubed minus 3x squared plus x minus 4. So what's the difference between the two? You're correct. So there is a fractional exponent in the first expression. So which do you think is a polynomial and which one is a non-polynomial? You're correct. The first expression is a non-polynomial, while the second expression is a polynomial. Since in the first expression has a fractional exponent, that is why we have here a non-polynomial expression. Second pair of expressions, we have the quantity of x plus 5 times the quantity of 9x plus 1 squared times the quantity of x minus 4. And then we have the quantity of x plus 5 times the quantity of 9x plus 1 squared all over x minus 4. So what's the difference between these two expressions? You're right. The position of the expression x minus 4. So in the first expression, the position is in the numerator, while in the second expression, the position of x minus 4 is in the denominator. So which one is a polynomial and which one is a non-polynomial? You're correct. The first expression is a polynomial, while the second expression is a non-polynomial. This is a non-polynomial expression because of the variable in the denominator. Based from the activity, we can define a polynomial as an algebraic expression that is the sum of the terms where each term contains variables whose exponents are non-negative integers. And a polynomial of one variable takes this form: a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus up to a sub 2 x squared plus a sub 1x plus a sub 0, where a is a real number. And we can conclude that all polynomials are algebraic expressions, but not all expressions are polynomials, because we have some restrictions for polynomials. A polynomial has no variable with a negative exponent. That is why in the activity, if we have 2x raised to negative 1, this is a non-polynomial since we have a negative exponent. Variable under the radical sign. It has no variable under the radical sign. Example, we have 2 the square root of x. This is not a polynomial since there is a variable under the radical sign. Another, it has no variable in the denominator. Example, we have 2 over x. There is a variable in the denominator and then a variable with a fractional exponent. Example, we have x raised to 3/4. So this is not a polynomial since the exponent is a fraction. Let us have some examples of polynomials and let us familiarize ourselves with its parts. The polynomial expression in standard form is written in this manner. Say for example, we have 31x raised to 7 minus 12x raised to 5 minus 15x cubed plus 2x squared plus 3x plus 5. This is a polynomial expression in standard form since the arrangement of the exponents is in descending order. The expression is a 7th-degree polynomial since 7 is the highest exponent. The leading term is 31x raised to 7 since this term contains the highest exponent. The leading coefficient is 31 since this is the numerical coefficient of the leading term. The constant term is 5 since it doesn't contain any variable, and the number of terms is 6. To find the number of terms, just count the terms separated by plus or minus signs. So let us complete the table below. So here we have 6 columns: polynomial, degree, leading term, leading coefficient, constant term, and the number of terms. So here, we have 3x cubed minus x raised to 4 plus x plus 3. The degree is 4 since the highest exponent is 4. Then the leading term is negative x raised to 4 since the term containing the highest exponent is negative x raised to 4. So it doesn't mean that if we have here the first term 3x cubed, automatically this is the leading term. So we have to choose or to analyze the given polynomial expression. Since this is not written in standard form, we have here 3x cubed minus x raised to 4 plus x plus 3. So in standard form, it must be negative x raised to 4 plus 3x cubed plus x plus 3. That is why we have here negative x raised to 4 as the leading term. Then the leading coefficient is negative 1 since the numerical coefficient of negative x raised to 4 is negative 1. Then the constant term is positive 3. The number of terms is 4 since we have 1, 2, 3, 4. 4 terms in this polynomial. Okay, so let us answer the following. You can use your scratch paper or you can answer mentally these exercises. Number 1, we have 2x plus 1. The degree is 1. What is the leading term? We have 2x. The leading coefficient is 2. The constant term is positive 1. And the number of terms is 2. Next number, we have x squared plus 6x cubed minus 5x raised to 5. What is the degree? Okay, that is right. We have 5. The leading term is negative 5x raised to 5. The leading coefficient is negative 5. The constant term is 0 since there is no term with no variable. And then the number of terms is 3. Next number, the degree is 4. Okay. We have the leading term is 2/3 x raised to 4. The leading coefficient is 2/3. The constant term is -4. The number of terms is 4. Last, we have x raised to 9 plus x raised to 8 minus 2x plus 3 plus x raised to 12. Here, the degree is 12. The leading term is x raised to 12. The leading coefficient is +1. The constant term is +3. And there are 5 terms. Our second objective for today's video lesson is to perform division of polynomials using the long division process. So let's try answering this problem. Find the quotient and the remainder when the polynomial x squared plus 6x plus 5 is divided by x plus 1. If you're going to use the long division process, so we have to write here x squared plus 6x plus 5 divided by the divisor, which is x plus 1. So make sure that the arrangement of the terms in the dividend is in descending order, the arrangement of the exponents. The same with the divisor. So the first step is to divide the first term of the dividend with the first term of the divisor. So x squared divided by x is just x. Then write it here, we have x. Then next is multiply x by the divisor, x plus 1. So this is x squared plus x. So we will write here minus the quantity of x squared plus x. If you will recall, this becomes plus and this is minus. This becomes negative or minus. So this is 0. 6x minus x is 5x. Then bring down plus 5. So next is to divide again the first term of 5x plus 5, which is 5x, by the divisor, or by the first term of the divisor, which is x. So this is 5. So you will write here 5. Then multiply again 5 by the divisor. So this becomes 5x plus 5. Then we have 0. So therefore, this is the quotient and 0 is the remainder. Let us answer this problem. Mang Isidro wanted to plant a mango tree that requires x minus 2 square meters of land. How many mango trees can be planted in an orchard whose area is x squared plus 3x minus 10 square meters? The given in this problem are x minus 2 square meters as an area of each mango tree, and we have x squared plus 3x minus 10 square meters. This is the area of an orchard. So what is asked in the problem is to find the number of mango trees that can be planted in an orchard. So to solve this particular problem, we can apply division of polynomials to find the quotient, which is the number of mango trees. So we have here the dividend, which is x squared plus 3x minus 10, then divided by the divisor, x minus 2. So we have x squared divided by x. We have x, so we will write it here. Then x times the quantity of x minus 2. This becomes x squared minus 2x. Then subtract. This would be 0. Then this becomes plus 2x. 3x plus 2x is 5x. Then bring down minus 10. We have 5x divided by x is 5. So we have plus 5. Then 5 times the quantity of x minus 2 is 5x minus 10. Subtract. We have 0. This is now the remainder. And this is the quotient. Therefore, to answer the problem, x plus 5 is the number of trees that can be planted in the orchard. The number of mango trees is x plus 5. Second problem. Find the quotient and the remainder when x cubed plus 4x plus 3 is divided by x plus 3. So we will write here x cubed plus 0x squared for the missing term plus 4x plus 3. Then divided by the divisor, which is x plus 3. So x cubed divided by x is x squared. So we will write here x squared. Then multiply x squared by the divisor x plus 3. So this becomes x cubed plus 3x squared. This is minus the quantity of x cubed plus 3x squared. Then subtract, this is minus. So 0x squared minus 3x squared is negative 3x squared. Then bring down plus 4x. Then we have 3x squared, negative 3x squared divided by x. This is negative 3x. So we will write here negative or minus 3x. The negative 3x times the quantity of x plus 3 is equal to negative 3x squared minus 9x. So this becomes minus the quantity of negative 3x squared minus 9x. This is plus, this becomes plus, then this is plus. This is 0, negative 3x squared plus 3x squared is 0, 4x plus 9x is 13x, then bring down plus 3. Then 13x divided by x is just 13, so we'll write here plus 13. Multiplied by x plus 3, this is x 13x plus 39. Then subtract, so this is 0, 3 minus 39 is negative 36. So negative 36 is now the remainder. And the quotient is x squared minus 3x plus 13 minus 36 all over x plus 3. Question number 3. Find the quotient when 2x cubed plus x minus 3x squared plus 8 is divided by x minus 3. So we will first rearrange the terms in the dividend. So this becomes 2x cubed minus 3x squared plus x plus 8. So make sure that the arrangement is in descending order, both the dividend and the divisor, divided by x minus 3. So divide 2x cubed by x. So this is 2x squared. 2x squared times x is 2x cubed. 2x squared times negative 3 is negative 6x squared. Then subtract, this becomes negative. So this is 0. This becomes plus, so positive. Negative 3x squared plus 6x squared is just 3x squared. Then bring down plus x. Again, we will divide 3x squared by x. So this is plus 3x. 3x times x, we have 3x squared. 3x times negative 3 is negative 9x. So subtract again. This is 0. X plus 9x is 10x. Then bring down plus 8. Then 10x divided by x is positive 10, so plus 10. 10 times x is 10x. 10 times negative 3 is negative 30. Then subtract, this is 0, and this becomes 38. So 38 is the remainder, while the quotient is 2x squared plus 3x plus 10 plus 38 all over x minus 3. So this is now our quotient. Now it's your turn. You may get your scratch papers to answer the following problems to check whether you have already learned the topic for today's video lesson. Okay, first problem. Find the quotient when x cubed plus 3x minus 1 is divided by x minus 3. Second, find the quotient when x squared plus 4x cubed plus x minus 2 is divided by x minus 2. Then third problem, Aling Maria, a tailor in Naga City, wants to make washable face masks for her family and relatives of equal lengths from a length of x squared plus 7x plus 12 inches. If each face mask is x plus 3 inches long, how many face masks can she make from the cloth? Special reminder, kindly answer the activity sheets in your modules. Thank you for listening.